Hi everyone! In this lecture we'll provide an overview of the hardware technologies for artificial intelligence and how they impact on AI applications. We saw that AI systems comprise the AI hardware layer, the intermediate AI software layer including frameworks, platforms and tools for AI, and the layer running the AI application. In this lecture we will detail the different families of hardware solutions for AI, and we will see that these families will scale from the tiny IoT devices that are characterized by severe technological constraints on computation, memory and power consumption, up to the large-scale data centers comprising multiple and high-performance servers for computation, storage and networking. So let's start now. Which are the technological solutions where we can find AI applications and software? Let's see some examples. In our homes, we have nowadays smart sensors that are able to measure the physical quantities and environmental quantities to control HVAC systems aiming at improving the comfort of people. More and more often, we interact with online systems through virtual assistants that are able to recognize people's commands and execute actions on their behalf. Smart cars are nowadays moving from the labs to our roads. Such novel generations of cars comprises several AI algorithms that are running in parallel directly on the car. For example, to detect the presence of pedestrians or to recognize road signs. Stock market predictions or personalized marketing suggestions are AI applications requiring a lot of computation and memory, and for these reasons, their execution is typically moved to the cloud or large-scale data centers. These are just examples of the wide range of hardware technologies for AI, but they allow us to shed the light on the fact that AI could be executed everywhere. Hence, all the technological solutions that surround us might represent a viable technological asset for AI. But in doing that, we must take into account the performance and technological constraints of each specific technological solution. Indeed, tiny devices will be able to support the execution of simple AI algorithms. More powerful technological solutions will be able to support more complex and more effective AI algorithms. We will show that the most promising point of view is not to see these units as single or independent devices, but we will see that the technology is moving towards an ecosystem of units, each of which takes part in the AI computation. So let's make a step ahead and try to formalize the available hardware technologies for AI. We can summarize the available hardware technologies for AI into 5 main families: data centers, edge computing systems, personal computers, embedded personal computers, Internet of Things devices. Let's start our analysis with the first family, data centers. They represent the most powerful and most performing technological solutions, since they comprise large-scale high-performing servers for computation, storage and networking. From this perspective, data centers represent the reference technological solutions for the cloud computing paradigm. This is a crucial point because the interplay between data centers and cloud computing plays a crucial role in the so-called AI as a service approach, by providing machine learning solutions as a service, machine learning platform as a service, and machine learning infrastructure as a service. We will see these approaches in detail in the next lectures. The second family is edge computing systems. They represent the novel player on the field. Edge computing aims at moving the cloud to the ground by providing computation and storage to process data close to where data are acquired. This is, for example, the technological scenario of smart cars or smart manufacturing in Industry 4.0, where data are acquired at high frequency and where such data must be processed locally and quickly to provide effective and efficient reactions, like, for example, slowing down a car or detecting a production problem. Going on, we find the third family, personal computers. This is the technological solution that is closer and more familiar to us. In our personal computers, we have intelligent algorithms for detecting spam emails, as well as many more algorithms that aim at supporting users and business. The recent years showed the importance of the fourth family of hardware technologies, embedded personal computers, that are able to pervasively operate in the environment, such as mobile devices or smart speakers. This family of technological solutions is becoming more and more important since they often provide the interplay between users and cloud-based computing systems. Hence, AI can run directly on the device, or the device is devoted to acquiring data through microphones, cameras, or accelerometers, just to name a few, while the AI processing is carried out on the cloud. Finally, Internet of Things devices are the last family of hardware technologies and represent the tiny pervasive devices operating pervasively in the environment. Often, these devices are battery-powered and the computation is carried out by means of microcontrollers. In addition, severe constraints on the available memory and flash memory significantly affect the running AI applications. Despite the constraints, IoT represents a very promising technological solution for distributing intelligence and supporting the so-called intelligent everywhere computing. In the next lectures, we will analyze these technological families in detail by describing characteristics and referencing applications, advantages and disadvantages. Furthermore, we will see that the technological evolution comprises not only these families of technologies, but also specific hardware devices meant to accelerate the execution of AI algorithms. That said, we have in front of us a very interesting journey embracing technologies and artificial intelligence.